Global warming is affecting us all, and electricity is becoming more expensive and harmful to the world around us. But now we have trigeneration, a cleaner and cheaper way to generate electricity. Conventional grid-supplied electricity is produced by coal-fired power plants kilometres from the city. Before it even gets to your business, almost 2/3 is lost in production and transmission. Trigeneration produces electricity on site, simultaneously generating power, heating and cooling. It is 85% more efficient, with the waste heat being used to provide heating and cooling for free. Trigeneration. Whether you need air conditioning, pool heating, or use heating and refrigeration in your production process, Simon's Green Energy offers a turnkey solution that saves you money and is better for the environment.
Hi students, I am Dr. A.R. Vijay Babu, working as an assistant professor in Department of EEE, Vignan's Foundation for Science, Technology and Research. So far we have gone through the first topic of the second unit in energy audit, conservation and management. Right. So the second unit consists of three different parts. The first part is cogeneration, the second part is trigeneration, and the third part is waste heat recovery. So we have successfully completed the first part, that is cogeneration. Now in this video, let's concentrate on trigeneration. So before going into this trigeneration video, let's see the learning objectives of today's class. So what is trigeneration? It's the first objective, and then the second one is what is the need of trigeneration, or what is the concept of trigeneration. The third one is the heart of this lecture, that is working of absorption chiller, and finally we'll see the benefits of trigeneration. So what is a trigeneration? The trigeneration is the simultaneous production of electricity, heating as well as cooling. We also call this trigeneration as CHPC, which means combined heat, power and cooling. As you can see in this diagram, fuel is used to drive an engine coupled with an alternator to generate electrical energy. Right? The primary focus is to generate the electrical energy. Here the engine acts as a prime mover. When we give the fuel to the engine, it will be converted into electrical energy. So after generating the electricity, whatever is the leftover heat or the byproduct of that engine will be utilized for hot water or steam, which will be used for space heating, or you may otherwise called as process heating. And whatever is the leftover after supplying the thermal energy or the heat or steam will now be utilized for chilling the water. Right, for chilling the water, and this chilled water may be utilized for either space cooling as well as for the process cooling. Space cooling is nothing but your refrigeration system or an air conditioning system. This process cooling is nothing but in industry we require some cooling water for some processes. That is what is called a process cooling. Right. So what is cogeneration? It's a simultaneous production of electricity and thermal energy, that is heat, from a single fuel source. What is trigeneration? It's a simultaneous production of electricity, thermal energy and cooling. So it from a single fuel source. Now, so a trigeneration is the process by which electricity, heat, cold were produced simultaneously. As you can see in the picture, there is a fuel which is given to the power system, and this power system is generating the electrical power. So whatever is the exhaust of this power system will be recovered, and that will be used for the heating. And after producing the sufficient heating, whatever is the leftover heat will be used in a thermally driven refrigeration system right, for getting the cooling refrigeration. So you are getting fuel, so you are getting electrical power, heating and cooling from a single fuel source. It is what is called a trigeneration. So what is this concept of trigeneration? So you can see it here in the industry, cogeneration is the most outstanding technique for simultaneous production of both electricity and heat. And this we have gone through it in the previous lecture. Now, if in addition to cogeneration, that is heat and electricity, some of the processes in the industry require of cooling levels below the ambient temperature, which means they may require cold air, cold water or ice. And if the cooling is produced from the same energy source, from the same fuel source, then this generation process, will call it as a trigeneration. The cooling can be done through the process of adsorption or absorption. You can see it here. We have taken a CHP, which means combined heat and power system, where we can generate electricity and heat from a single fuel source. And here we can see, after giving input to the CHP, that CHP produced electricity as well as the thermal energy, it is the heat. And some part of heat will be utilized in the boiler to generate the heating load. And whatever is the leftover heat, after supplying it to the heating load, that part of the heat is supplied to the absorption chiller. And this absorption chiller can do two things. It will produce the chilled water for the cooling requirement. On the other hand, it will also use the chilled water in the HVAC system for getting the air conditioning or refrigeration system in our industry. Right. So what is HVAC? Heating, ventilation and air conditioning systems to produce the cooling effect. It is how the trigeneration will work. It is the concept of trigeneration. Now you can see it here. There is a fuel which is given to an engine or a gas turbine, and that will be coupled to the generator to produce the electrical energy. And that electrical energy, we are supplying it to a building or a facility or an industry. Right. And whatever is surplus of electricity, that we can send it to the grid. That we can sell it to the grid. And then the exhaust of this generator, that is the waste heat, is recovered in a heat recovery unit and will take the hot water or steam to the building again. So whatever is the leftover heat or the low grade heat available after converting the waste heat into thermal energy or the heat energy will now be utilized in the absorption chiller for producing the cooling water, and that will also be supplied to the building or facility or an industry. You can see it here, from a single fuel source, we are supplying the electricity to the building, we are supplying hot water to the building, and we are supplying the cold water to the building or facility or an industry. It is what is called the trigeneration. The adsorption chillers can use the hot jacket waters or the hot exhaust gases to produce the chilled water. The absorption chillers provide an economical and environmental friendly alternative to conventional refrigeration system. Why? Why they are providing a sustainable alternative to the conventional way of refrigeration? Because the absorption chillers allows for maximum total fuel efficiency, as well as it will eliminate the harmful refrigerants and reduce the overall air emissions that will come when the normal or the traditional refrigerants are used in the system. That is, instead of using the traditional refrigerants, that is R13 or R22, which will be used in our ACs, it will use water or ammonia or lithium bromide as a refrigerant. And these three things, they are not the global warming gases. And that's why it is environmental friendly technology. Right? As you can see it here, there is a cogeneration technology, which you can see in the slides over here. This cogeneration means if I give a fuel to it, I will get the power and heat. And the engine will produce some exhaust gases. And that exhaust gases will be used in the absorption chiller for getting the cooling. Right. So, on a whole, the trigeneration is nothing but a cogeneration plus a absorption chiller. So, we can convert a cogeneration system by adding an additional equipment called absorption chiller. So, a trigeneration is nothing but a combination of cogeneration and absorption chiller. Coming to the efficiency point of view, in order to generate the electrical energy by means of a generator, the efficiency will be around 35 to 40%. Whereas to generate the electricity and heat by means of a cogeneration system, here the efficiency is 50 to 70%. Here the efficiency got improved because we are utilizing the same fuel for producing the electricity and heat. Now by using a trigeneration system, obviously the efficiency should be much higher. It will be around 80 to 90% because we are using the same fuel for generating electricity, heat as well as the cooling, and thereby we are eliminating the extra fuel which is required for producing the cooling. That is why the efficiency is improved to about 85 to 90%. You can see a typical example here. There is a trigeneration system. I have given 100% combustible fuel. That is, a fuel is combusted, and then I am getting 30% electricity and 55% I will get it as heat and cooling. Both are called thermal energy. It may be either heat or cooling. And what is the leftover 15%? That is a losses. 13% of the heat losses and 2% of the transmission losses. So overall 30% electricity plus 55% heat and cooling. So what is the final output we are getting? 85%. That is, of the 100% fuel we are giving it to the trigeneration system, we are utilizing 85% of it for producing electricity, heat and cooling, and the remaining 15% is a waste heat. And this waste heat we can also use it to improve the efficiency of a system. That we will see in our third topic, that is waste heat recovery. So whatever is the waste heat which is left here, that 15%, even this waste heat also we can use it to improve the efficiency further, and that we will see in our next class. Right? Then what is an absorption chiller? An absorption chiller. So what is an absorption chiller? An absorption chiller is a device which uses heat to generate cooling. This absorption chiller is the heart of the trigeneration system. Right? So it will uses heat and it will convert that heat into cooling. An interesting point to note about absorption chiller is that they don't use conventional refrigerants as already discussed. Instead, they use water as a refrigerant, and this is mixed with either ammonia or lithium bromide. So that is why it is environmental friendly technology, because it is not producing any CFCs, and chlorofluorocarbons, into the atmosphere. So this lithium bromide is more commonly used because it is more safer and non-toxic when compared to ammonia, and that's why in the absorption chiller generally we will use water and lithium bromide solution as a refrigerant. So before understanding the working of a absorption chiller, let us focus on three important concepts of this chiller and why water and lithium bromide is used. If you know these three concepts, then we will be able to understand the working of an absorption chiller in a better way. The first concept is evaporation and boiling point of water. So when we boil water, it changes its state from a liquid into a vapor. Right. So water boils at different temperatures under different pressures. So if you increase the pressure, then water boils at much higher temperatures. And if you decrease the pressure, then water boils at much lower temperatures. That is, boiling point of a water is directly proportional to the pressure, not temperature. So the boiling point of a water is directly proportional to the pressure. As the pressure increases, the boiling point of water also increases. As the pressure decreases, the boiling point of the water also decreases. Right? Let's see an example to understand this concept 1. So generally, we are used to water boiling at around 100 degrees centigrade because the atmospheric pressure around us is about 101 kilopascals or just 1 atmosphere. Right? The boiling point of water is 100 degrees centigrade at 1 atmosphere. But if we take this same water and we'll keep it at some high altitudes, or for example, take it to the top of a Mount Everest and heat it, then what happens? The water will boil at around 70 degrees centigrade itself. The same water, when we keep in the room, will be boiling at 100 degrees centigrade. But when we took the same water to the top of a Mount Everest, the same water will boil at around 70 degrees centigrade. Why? Why it is boiling at 70 degrees centigrade? Because the atmospheric pressure at the top of the Mount Everest is only 34 kilopascals or 0.34 atmospheres. That is, the pressure got reduced. So as we already know that the boiling point is directly proportional to the pressure. As the pressure decreases, the boiling point also decreases. So you can see as the pressure got decreased, the water boils easier even at 70 degrees centigrade. On the contrary, if water is placed in a vacuum chamber, so what is a vacuum chamber? A chamber which is having very low pressures or zero pressure. Then it will boil at extremely low temperatures. So in the absorption chiller, both the evaporator and absorber chambers are kept at near vacuum conditions. That is at around 0.84 kilopascals or 0.0084 atmosphere is negligible pressure. So the water boils at around 4 degrees centigrade. The water boils at around how many degrees centigrade? 4 degrees centigrade. You can see as the pressure becomes negligible, the boiling point also becomes negligible. So when the pressure is 1 atmosphere, the boiling point is 100 degrees centigrade. When the pressure is 0.34 atmospheres, the boiling point reduced to 70 degrees centigrade. And when the pressure got reduced even below 0.0084 atmospheres, then the boiling point of the water reached 4 degrees centigrade. So a very little energy is required now to boil off the water. You can see it here. At the sea level, the boiling point of water is 100 degrees centigrade because the pressure is 1 atmosphere. At the high altitudes, the boiling point of the water is 70 degrees centigrade because the pressure reduced to 0.34 atmospheres. And in the vacuum chambers where the pressure is very low at around 0.0084 atmospheres, you can see the boiling point further reduced to 4.5 or 4 degrees centigrade. Therefore, by varying the pressure inside the absorption chiller, the water and lithium bromide which is used in it are able to easily change phases between liquid and vapor, which is essential to produce a cooling effect. Right? Now, the second concept is lithium bromide is a salt and it will attract water vapor. That is, the second thing to understand is that the lithium bromide is a salt, like a normal salt in our home. But it will be in a liquid form. The salt in a liquid form is a lithium bromide. So generally salt attracts moisture. So in the same way, this lithium bromide also will attract the water vapor. Right? And the two will mix out each other perfectly when they come in contact with each other. As you can see in the animation there, the bottom one is a lithium bromide salt, the top there is a water vapor, and when they mix it or when they come in contact with each other, they will mix with each other perfectly. That is, this lithium bromide has a strong affinity towards water vapor. Fine. It is the second concept which we need to understand in order to understand the working of an absorption chiller. The third concept is So after they got mixed up with each other, how can we separate those two? There's a separation of lithium bromide and water vapor. So the third thing we need to understand is that water and lithium bromide can be mixed together. But if you add some amount of heat, then both will separate. The water will rise and evaporate, and the lithium bromide will sink to the bottom of the container, because water is having very low density and it will move upwards by becoming vapor. And whatever is the leftover lithium bromide, because of its heavy nature, it will sink to the bottom of the tank or the container in which it was kept. It is the third concept we need to understand. Right? Now what is the first concept? The first concept is boiling point of a water is directly proportional to the pressure. As the pressure decreases, boiling point decreases. As the pressure increases, the boiling point also increases. The second concept is mixing of lithium bromide and water vapor. When they both come in contact with each other, because lithium bromide is a salt, it has strong affinity towards the water vapor and they will mix together perfectly. And the third concept is the separation of lithium bromide and water vapor. When you heat the mixed solution of lithium bromide and water, then water will get evaporated and move upwards. Lithium bromide got settled at the bottom of the container in which it was kept. Now, after getting the essential three concepts which are required to understand the working as an absorption chiller, now let us straight away enter into the working of an absorption chiller. So this absorption chiller consists of four parts. The absorption chiller consists of four main parts: condenser, generator, evaporator and absorber. The condenser and generator are the most important parts of a absorption chiller and they form the top chamber. And the remaining two parts, that is the evaporator and absorber, comprises the bottommost chamber. And we have one more device called heat exchanger, which is used in this trigeneration system to improve the efficiency of the system. So we have five components on a whole. Condenser and generator forms the topmost chamber, evaporator and absorber forms the bottommost chamber, and we have a heat exchanger to improve the efficiency of a trigeneration system. Right? Initially, as you can see here, the operation starts at absorber. In the absorber, a mixture of around 50% lithium bromide and 40% water is pumped from absorber into the generator, which is located in the topmost chamber, through a heat exchanger. This generator section acts as a reservoir for the mixture of lithium bromide and water. So the generator is otherwise called a reservoir of the lithium bromide and water solution. So now, heat in the form of hot water or steam is added to the generator or reservoir where there is a mixture of lithium bromide and water exists. So when you add heat to the solution, what happens? We have seen in the third concept, that is, when you heat it, they will get separate with each other. Right? So thereby, when you add the heat, that is hot water or steam, to the generator section of the topmost chamber of the absorption chiller, that heat will be sufficient to separate the water, to separate the solution of the lithium bromide and water into two constituent parts, that is water vapor and lithium bromide. Water vapor, being light in nature, will move upwards and it will be settling down in the condenser section of the absorption chiller. And the heavy lithium bromide particles will sink to the bottom of the generator, and from there they will flow down through the heat exchanger to be sprayed over the absorber again. So by doing so, the absorber will go and mix with water again to be again sent into the generator for next cycle. Meanwhile, the water from the cooling tower passes through a sealed pipe within the condenser to remove the heat of the water vapor, which causes it to condense into a liquid. So what happens in the meanwhile, this water vapor which is there in the condenser section, now we will pass the cool water into this condenser section by means of a cooling towers. Now what happens, the cooling water of the cooling tower will cool this water vapor, and that water vapor will now condense into liquid, and that liquid water will again collected in a tray within a condenser and will flow through a pipe down to the evaporator which is there in the bottom component or the bottom chamber. Since the evaporator is operated at a very low pressure, that is near vacuum condition, that is 0.0084 atmospheres, this causes the water to flush and drop its temperature to around 4 degrees centigrade due to rapid drop of pressure, as we have seen in the concept number 1. As the pressure reduces, the boiling point of water also will reduce, because the evaporator and absorber will be kept under vacuum condition at a low pressure condition of 0.0084 atmospheres. The boiling point of water at this pressure will be only 4 degrees centigrade. Right. And there is one more loop called chilled water loop. Now this chilled water loop will now run into the evaporator, bringing all the unwanted waste heat collected from the building. So this chilled water is a water which will collect all the unwanted heat in the building or facility from the refrigeration units or the fan coil units or from other ACs, and that will be given and that will be sent into the evaporator. And this chilled water is a carrier for the waste heat which is coming from the industry or an organization. So the cold condensed water, so that is the water coming from the condenser which are at a 4 degrees centigrade, will now be sprayed over the chilled water tube. Now the condensed water which are at 4 degrees centigrade will now be sprayed onto the chilled water tubes. Why? Because the chilled water will enter the evaporator at 12 degrees centigrade, at around 12 degrees centigrade, and it will transfer all the unwanted heat collected from the building to the condenser water sprayed over the chilling water tube. That is, in the evaporator what happens, there are two streams. One is a chilled water stream and other one is a condenser water stream. This chilled water stream is at a temperature of 12 degrees centigrade. So it is the one which is carrying all the waste heat to the evaporator. And there is one more stream called condenser water which is at a temperature of 4 degrees centigrade. So normally heat will flow from high temperature to low temperature. So the heat which is available in the 12 degrees centigrade chilled water will now move to the condenser water. That is, it will lose its heat by 4 degrees centigrade, because the condensed water is at 4 degrees centigrade. This chilled water will lose its heat by 4 degrees centigrade. That is, the chilled water which is entering the evaporator at 12 degrees centigrade, after being sprayed by the condenser water, it will reduce its temperature to around 8 degrees centigrade while it is moving out of the evaporator. Right? So here we need to remember one thing: the two streams, the chilled water stream and the condenser water stream, will never mix with each other. They are always kept separate and are separated by a pipe wall. So the absorbing the heat from the chilled water, the condensed water which is at 4 degrees centigrade will evaporate into steam due to vacuum inside the evaporator. What I told you? Now the boiling point of the water in the evaporator will be 4 degrees centigrade. Now I am giving 12 degrees centigrade heat. That is, 4 degrees itself is enough to convert that condensed water into steam or water vapor. That is what happening here. And the remaining 8 degrees centigrade chilled water will move outward of the evaporator. Is that clear? The chilled water will enter at 12 degrees centigrade. Now the boiling point of water will be only 4 degrees centigrade in the evaporator, because it is operating at a very low pressures of 0.0084 atmosphere. Now inside this bottom chamber or inside this evaporator, if we send a water, and if I can provide 4 degrees centigrade temperature, that it will be sufficient to convert that water into steam. Now the chilled water at a 12 degrees centigrade will enter this evaporator, and the condensed water will come from top chamber to the bottom chamber, right? So as soon as this condensed water falls on the or sprayed onto the chilled water pipes, this chilled water pipes will given away its heat to the sprayed condenser water, or otherwise this condenser water will absorb the heat from the chilled water. That is, the condensed water which is at 4 degrees centigrade will absorb the heat from the chilled water which is at 12 degrees centigrade. So by increasing its temperature to 4 degrees centigrade, the condensed water will now becomes steam or water vapor, right? And after losing 4 degrees centigrade, this chilled water will now becomes 8 degrees centigrade, and that chilled water at 8 degrees centigrade will leave the evaporator. So the chilled water circuit has given up all the unwanted heat. So the chilled water circuit has given up all the unwanted heat by the time it leaves the chiller. Now what happens? So it should be around 8 degrees centigrade, and this water is now ready to pump back into the building again to collect more unwanted heat and bring it back to the absorption chiller. So it is the heart of this absorption chiller operation. This chilled water is the heart of this, is the important concept of this absorption chiller. So this chilled water loop or the circuit is the one which will bring the unwanted heat from the building or from the cogeneration unit into this evaporator. Is that clear? It is how we will keep the absorption chiller in the trigeneration system. In the cogeneration system, we will produce electricity and heat. After producing both electricity and heat, whatever is the leftover heat, that heat will be bring back to this evaporator by means of a chilled water circuit, and this waste heat will be utilized for converting into cooling. That is why in the trigeneration we will get heating, cooling and electricity generation. That's why a trigeneration is nothing but a combination of cogeneration system and absorption chiller. Then the water recirculation loop is one more loop which is there in the evaporator section itself. So this water recirculation loop will recirculate any water that missed the chilled water tubes and didn't boil off into steam. And that amount of water will be again pumped back to the top of the evaporator by means of a recirculation loop or a recirculation pump, and it is sprayed again and again and again until all of it will evaporate into steam. You understand this one, right? It's very simple, right? Whatever is the water coming from the condenser that didn't pass it through this chilled water tubes or which escapes the chilled water tubes will collected in the tray in the inside of the evaporator, and that water will be again sent onto the top of the evaporator to be sprayed again onto this chilled water pipes, so that water also will again converted into steam or water vapor, right? So the water vapor or steam produced by the evaporator is then strongly attracted by the lithium bromide solution being sprayed in the absorber from the heat exchanger, right? You can see it here, what we have seen. So after giving the hot water or steam to the generator section, the lithium bromide and water solution will dissolve into two components. The water vapor will go into the condenser section, and that lithium bromide will be fed back into the absorber through heat exchanger. Right. So in the bottommost chamber, we have a lithium bromide solution, and in the top part of the bottom chamber, we have an evaporator where there is a steam or water vapor. Right. So this the second concept which we have seen is what? The lithium bromide has a strong affinity towards water vapor, and when they come in contact, they will mix with each other perfectly. Now what happens in the bottommost chamber? We have the water vapor as well as the lithium bromide. So both will mix with each other. So when these both mix with each other, they generate a little amount of heat, and that heat needs to be removed from the absorber in order to improve the efficiency of the system. But how could we do that? For that, we'll use the cooling tower water loop, and we'll make it pass through the absorber to carry away this little amount of heat which is produced because of the mixing of lithium bromide and water vapor. It is how the system will work. It is the concept of a absorption chiller.
Let's look at the main components of there. So in the top chamber, we'll always have the condenser and the generator. In the lower half of the chiller, we'll always have the evaporator and the absorber. And then on the side, down below, near the bottom, we'll also have a heat exchanger. The heat exchanger is just there to improve the efficiency of the system. So first of all, a mixture of around 60% lithium bromide and 40% water is pumped from the absorber through the heat exchanger and then rises up and pours into the generator tank at the top of the chiller. Now this line is often referred to as the weak solution line, and that is because the lithium bromide is mixed with the water, so it's a weak solution. The generator then fills up with this mixture of lithium bromide and water, creating a reservoir. Next, heat is added to the reservoir containing the lithium bromide and water, and this will begin the separation process that we saw earlier. Now this heat is usually in the form of waste heat and will typically come from hot water or steam that's being pushed around a heat exchanger of tubes inside the generator. The heat from this hot water or steam causes the lithium bromide and water to separate. All the water particles will start to boil off and will fill the condenser with a hot water vapor or steam. Then the heavy lithium bromide particles will sink to the bottom and form a concentrated liquid. This hot liquid flows down to the heat exchanger where it transfers its heat into the weak solution line, running in counterflow. Once the concentrated lithium bromide liquid has cooled down, it makes its way to the absorber where it is sprayed onto the chamber and will mix with the water before again being pumped to the generator to repeat the loop. But we will look at this part in more detail in just a minute. Next, we want to condense the hot water vapor in the condenser to bring it back to a liquid. So we pass water in a sealed pipe through the condenser and circulate it around to the cooling tower where it will be able to reject all the heat that it collects. The temperature of the cooling tower water is enough to cause the hot water vapor to condense into a liquid as it comes into contact with the surface of the pipe, so it will rain down and collect in the collection tray just below, just here. Once it collects in the tray, it will start to flow down to the evaporator and will be sprayed into the chamber. The amount of water that can flow is restricted by a small orifice in this pipe. Now the evaporator, as we mentioned earlier, is at a very low pressure. It's almost near a vacuum condition. Now this sudden change in pressure will cause that water that's entering to suddenly flash and drop in temperature into a cold water of around just 4 degrees Celsius, maybe 40 degrees Fahrenheit. A chilled water loop then runs into the evaporator, bringing all the unwanted heat from the building, which was collected from the AHUs and the fan coil units, etc. So this cold condensed water will spray over the chilled water tubes and cover the surface of the tube with a thin film of cold water. The chilled water will enter at around 12 degrees Celsius, 54 degrees Fahrenheit, and this will transfer its thermal energy, its heat, all the unwanted heat from the building. It will transfer that through the tube wall and into the low temperature water film, which was sprayed across the outside of the chilled water tubes. Remember, the two waters never mix, they're always kept separate, and they are separated by the pipe wall. As this heat transfers into the water on the outside of the tubes, this outer water will evaporate into a steam or water vapor due to the low pressure of the chamber. As it evaporates, it carries away all the unwanted heat with it. And remember, earlier we did learn how water boils at lower temperatures under low pressure. So the chilled water circuit has now given up all the unwanted heat, and by the time it leaves the chiller it should be around 7 degrees Celsius, which is approximately 45 degrees Fahrenheit, and this water is now ready to be pumped around the building again to collect more heat and bring it back to the absorption chiller. Another loop will recirculate any water that missed the tubes and didn't boil off into steam or water vapor, and this will be pumped back to the top of the evaporator and sprayed again and again and again until all of it evaporates into steam. Now all of this water that's evaporating into water vapor and steam will build up and collect and around the evaporator chamber, and this water vapor or steam is then attracted and pulled towards the strong lithium bromide solution being sprayed in the absorber, almost like a magnetic force. The attraction is so strong that water particles flow by themselves straight to the absorber to be together with the lithium bromide particles. This strong, almost magnetic attraction between the water particles and the lithium bromide particles is what causes the vacuum in the chamber. The lithium bromide attraction for the water is so strong that it will pull the water particles inside its own fluid and it will all mix together. The stronger the concentration of lithium bromide, the stronger the attraction will be for water particles. When the two fluids come in contact, they generate a little heat, and this, as well as the heat collected from the chilled water loop, needs to be removed. So that is why the cooling tower water loop also passes through here to take the unwanted heat away. Now the cooling tower water will also condense any of the residual water vapor particles or the lithium bromide particles and turn this back into a liquid. And once this has occurred, the mixture of lithium bromide and water is collected at the bottom of the tank in the bottom of the absorber, and it is now ready to be pumped back to the generator again to repeat the entire cycle. So there you have it. That's the basic operation of how an absorption chiller works.
So finally, what are the benefits of trigeneration? On-site generation of high efficiency production of electricity, cooling as well as heating from a single fuel, and thereby the amount of fuel required to produce these three independently will be reduced in a trigeneration system. As the amount of fuel got reduced, this will reduce the fuel and energy cost. Right, so lower electrical usage during peak summer demand. Right, we can use the electricity from our campus itself, from the industry itself, when there is a shortage of power in the summer season. So on the other hand, the fourth benefit is engine heat can be used to produce steam or hot water for on-site use. And the fifth advantage is significant reduction in greenhouse emissions. Obviously, as the fuel required to produce electricity, heat and cooling got reduced, obviously the greenhouse gas emissions are reduced. And finally, no harmful chemical pollutants, since water is used as a refrigerant. So in the trigeneration system, we are using absorption chiller, and the absorption chiller will use water and lithium bromide as a refrigerant in place of a traditional refrigerants like R13 and R22, and thereby there is no CFCs, that is chlorofluorocarbons, emitted into the atmosphere. So let me conclude today's class, that is trigeneration. We have gone through the concepts of what is trigeneration. So what is a trigeneration? A trigeneration is a simultaneous production of electricity, heating and cooling from a single fuel source. Then what is the concept of trigeneration? The concept of trigeneration is nothing but I have to take a concentration system and I need to add the absorption chiller to it to get the cooling from it. And from the concentration system, we'll obviously get the heating and electricity. So from a single fuel, we are getting all the three. That is, trigeneration system is obtained by adding absorption chiller to the concentration system. That is, trigeneration is equivalent to concentration plus absorption chiller. Then we have gone through three essential concepts which are required to understand the working of an absorption chiller. The first concept is the boiling point of the water is proportional to the pressure. As the pressure increases, the boiling point of the water increases. As the pressure decreases, the boiling point of the water also decreases. The second concept is that the lithium bromide has a strong affinity towards the water vapor. So when they come in contact with each other, they will mix with each other perfectly. The third concept is the separation of lithium bromide and water solution. So how we can separate it? If we add some heat to the solution, they will get divided into again water vapor and lithium bromide. The water vapor, being light in nature, will move to the condensation section, and the lithium bromide, because of its high weight or high density, will settle down at the bottom of the container. Right, it is the third concept. So after going through these three essential concepts, we have now understood the working of the absorption chiller. And finally, we have gone through different benefits of absorption chiller. The main important benefit is that the fuel cost is reduced. The fuel required is reduced, and thereby the emissions produced are reduced. On the other hand, one more important benefit is that because of using water as a refrigerant instead of a conventional refrigerants, the chlorofluorocarbons are not released into the atmosphere, and thereby we are reducing the global warming. So in the next class, we will see the third part of the second unit, that is waste heat recovery. Thank you.